Hi guys, welcome to your 9R2 intro notes. The first part of 9R2 is reviewing the 5 techniques that we've studied and know when, and now it's kind of important to know when to use them. When is that technique a great technique to use? So if you can print this worksheet or just take notes, that's fine. So this will really help you on your Chapter 9 assessment, when certain techniques are best to use. So it says, there are 5 techniques for solving quadratic equations: graphing, square roots, factoring, complete the square, and the quadratic formula. So when is it best to use each one? Well, graphing is great when they cross at exact locations, but maybe it's small numbers. Maybe you have graph paper. When is it best to use? Maybe when you have graph paper, or maybe you can use Desmos. But I'll be honest, graphing would not be the technique I would ever choose to use. It's hard to see where they're crossing exact, and if your points are off just a little bit, I would rather use some algebraic techniques such as the square roots, the factoring, the complete the square, the quadratic formula. So personally, I would avoid graphing. That's just my personal opinion. When is it best to use square roots? Square roots are best when all you see is an x squared and maybe a constant. So you don't have an x variable in there. You don't see like x squared plus x plus 4 equals 0. You don't see an x squared and an x. That's a big no-no. With square roots, if you just have a section squared, a variable squared, or even a whole chunk of information squared equal to a number, those are a great time to use square roots. So if you have an x squared or a section squared, that is a great and easy breezy time to use square roots. They'll work really well. But if you have that middle x term, you cannot use square roots. You can only have a squared term and the other value. Factoring. Boy, if it factors, use this technique. If it's a factorable problem, factoring is probably the easiest technique to use. So, for instance, I'll make up a quick factored question that works. This is one I would definitely use factoring. Why? Because it factors. So I'm thinking of numbers that multiply to give me 6, 1 and 6, 2 and 3, that add to give me 5. Well, that's easy breezy. It's 2 and 3. And then you set your chunks equal to 0, and you solve. So a lot of you realize you just take the opposite. So -2 and -3 are your 2 zeros. So if it's factorable, factor it. But here's a problem. Some of these, that's not factorable. There are no 2 numbers that multiply. Well, think of all the numbers that multiply to give you 1. It's 1 times 1. Do those add to give you 4? No. There are no 2 numbers that you will be able to find that multiply to give you 1 that add to give you 4. This is called prime. It's not factorable. But that doesn't mean it's not solvable. That just means that factoring is not the best approach. So if you had a problem like this, you could use one of the last 2. You can use complete the square or the quadratic formula. This one would work quite well with complete the square. Why? Because the middle term is a number that's easy to cut in half. Remember the song, move C to the right, middle number divide, square it, add that value to both sides, factor add, solve it right. It would be wise to make sure that the middle number is something that's easy to cut in half. So if this were a 3, oh, definitely, I would not use complete the square. So if something's not factorable and the middle value or B value is an even number that's easy to cut in half, complete the square is a great technique. But let's say this was this. X squared plus 3x plus 1 equals 0. That's definitely one for the quadratic formula. Here's why. 1, it's not factorable. There are no two numbers that you can think of that multiply to give you 1 that add to give you 3. They just don't exist. And I wouldn't want to use complete the square on this. Why? Because I'd have to cut 3 in half. No, thank you. I'd get some weird funky fraction. Not my jam. And let's review, why can't we use maybe square roots? They're so easy. It's because we have that middle term. You can only have a squared term and the constant. A squared term and a constant for square roots. So if it factors, I go with factoring. If I just see a squared term, I go with square roots. If it's not factorable, but the middle is a number that's easy to cut in half, so it's an even number, I can use complete the square. Or of course, quadratic formula is a catch-all. It works for anything. All you have to do is identify your ABC, and quadratic formula will work. And those are the various techniques that you have, okay? Great, thanks. Go ahead and print your 9R2 notes, and we'll get started on those. Bye.